Today, let's get started with Kubernetes. As we discussed in the last session, Kubernetes is an orchestration tool, or we call it as container management tool, right? So let me quickly explain where Kubernetes come into picture. So for example, this is the development team, and we have code in Git. This is development team, we have code in Git. We take the code and then we build it and then we create EMIs, right? So this is our application code, and we create EMIs here. So let me just connect this. Now, this is our warfare application code, and we have created the image. The image name is gamut-cart-image. So first we clone the code. Second, we do build. Third thing, we have to create image, and then we have to deploy that image using Kubernetes to create the environment. That is creating environment, right? So here, these 10 containers we are going to run inside Kubernetes cluster. So this is Kubernetes K8s in short. Let's think it as, maybe 10 or 20 containers, whatever you want. Load balancer. Why Kubernetes first? So as we discussed in the last session, Kubernetes is an orchestration tool, right? We can create the image, and using some shell Perl kind of scripts, we can go and then deploy the image. That means we can go and then create the container, but we have to take care of a lot of other things. For example, as we discussed, assume that we have some new code right here, and here we have old code, and if you want to deploy this new code into this Kubernetes cluster without bringing environment down, it is very difficult for us. We call that as zero downtime release, or we call it as a blue-green deployment. Zero downtime release. So we call that as application, rolling updates, right? Rolling updates. Second thing, we use Kubernetes to actually make the environment self-heal. In the sense, assume that at any point of time, to serve our application based on the topic, we need 100 containers. If 10-20 containers go down, we should be able to automatically bring the new containers, correct? And if you want to do that, very difficult for us. So that's where Kubernetes come into picture. We call that as self-healing. Third thing, using Kubernetes, we can also auto scale the environment based on the load or based on different parameters. Fourth step, application rollback. When we deploy the new code, and if that code is not working properly, we should be able to roll it back. If we have containers in Kubernetes, containers running in Kubernetes cluster, we get all these features. Kubernetes is also, the clustering software. You'll understand what is clustering later when I explain that slide. So I have slides for Kubernetes. Okay, let me just go with some theory. Let me first explain what is Kubernetes, and then the history of Kubernetes. So as I said, Kubernetes is orchestration tool or container management tool. You can also call Kubernetes as data center OS. Why we call it as data center OS? I'll explain that later. A short background about Kubernetes. Kubernetes is actually came out of Google. So as we know, Google has been using containers from very long, almost 13 to 15 years now, and there are billions of containers. So they thought of creating a homegrown tool to manage their containers, and the tool was Borg. Later that they changed the name to Omega, and then they open sourced that homegrown tool, the project. That's where now Kubernetes evolved. Whoever worked on this Google internal tool, right? So those people work for Kubernetes. It's not actually a copy of their homegrown tool, that is Borg or Omega, but whoever worked in that project, they contributed to Kubernetes. And Kubernetes is actually donated to an organization called CNCF, Cloud Native Computing Foundation. So these guys are managing Kubernetes now. And Kubernetes is developed in Golang. Golang is again from Google, right? And yeah, so in short, we call Kubernetes as K8s. K8 in the sense, like before K and then S, we have 8 characters. That's how we refer it. That's a background about Kubernetes. Okay, why Kubernetes, for our environment, correct? So these are the reasons. I have already explained these things for you. Rolling update, self-healing, auto scale, rollback, and stuff like that. These are the deployment challenges we face in real time. So once we create the image, then if you want to manage all this, if you want to manage your environment with all these features, then it's a kind of a nightmare for us. That's where we call Kubernetes. So I've just given some notes here in the slide. You can just check these things later. Okay. Kubernetes gives us all these features. Again, it gives all these features without we writing much code, basically. In the sense, so as I mentioned before, if you want to, say, perform this rolling updates in real time, this is what we do. For example, assume that we have, say 100 containers, right? How do you deploy the new code without bringing it down? So typically, this is what we do. For example, we take out 50 machines from the traffic, from the load balancer, and only remaining 50 machines are actually serving the traffic. Then we go and deploy the new code in this 50 servers. And then we switch the traffic from the old, these 50 servers to new code. You call this as a clusters. Okay, this is cluster 1, cluster 2. So you first take out some missions out of the traffic. You call it as cluster 1, for example. You call it as cluster 2. Users are accessing application by connecting to this. You deploy the new code here, and then you switch users from here to here. Now these missions have got new code, and this cluster still has the old code. Again, what we do, we deploy new code to these missions, and then we again direct users to these 50 servers, and then we see if everything is fine or not. Now once this cluster is good, then we merge 100 servers under one load balancer, and all our 100 servers are up and running with the new code. See, if you want to handle this, you have to write thousands of lines of code. Basically, Kubernetes can give all these features without we writing much code. In Kubernetes, we write something called declarative configuration file. What's that? Declarative. So if it is Kubernetes, you can just tell Kubernetes saying, I want you to update the existing environment with the new code. And say, for example, say you want 100 containers here, right? You just need to write something called YAML file here. YAML, we call it as a declarative configuration file, or you call it as manifest file. So once the image is created, we write this YAML file. For example, here in this YAML file, I say, I want 100 containers from this particular image, and I want this port to be open, for example, 8080. So we just write the information, the configuration at a very high level in a declarative syntax like this, and then you give it to Kubernetes. Kubernetes can create the environment for us based on our requirements. Correct? We call this as what? Declarative syntax. That means without writing much code, you just specify what you want, and then the how part will be completely taken by Kubernetes at a very high level. So it's very easy if you have, it becomes very easy for us to handle all these things if we have Kubernetes. Correct? We call this as a desired state. What's that? Desired state. Desired state. You tell Kubernetes what desired state you want, and Kubernetes will get it done for us. For example, once the desired state is implemented, you call this as actual state. Kubernetes brings your desired state to the actual state, and then it also continuously monitors your environment to make sure that actual state is always matching desired state. What is the desired state here? I want 100 containers from this image, on this port. If, for example, right, 10 containers go down, that means your environment is not matching your desired state, right? So what it will do? It will go and then repair. It will go and then bring 10 containers up for us. So that's the terminology we use here: desired state, then actual state. Okay, that's how Kubernetes work. Just a simple analogy, right, to say why Kubernetes is called as an orchestrator tool. What do you mean by orchestration? First, see this: you go to you go take any game, for example, you could take cricket or football or whatever. In cricket, for example, if you want to win the game, right, you have to deploy your players according to their strength, right? So for example, one player may be very good in fielding, say front. This player is very good in running, basically, so you deploy him in the boundary lanes, for example. And this player may be very sharp in say catching the things. So if you don't deploy these players in proper field place, very difficult for us to win the game. So who plans all these things in any game? We call them as coach, correct? Or you call them as captain, correct? So in sports world, we call this as a captain or coach, and in application world, we call that as orchestration. Means it knows where to run your application, right, with what configurations and stuff like that. For example, here we have, say, 100 containers, right? In these 100, few containers may be database servers. Few are, say, for example, Tomcat servers. There may be some payment gateway servers. And when this mission goes down, you have to bring the new mission with the same configuration, right? For example, we might have given, say, 4 GB dedicated RAM and maybe 2 cores or 3 cores CPU. So in microservice world, we run different services in different missions. When you deploy the containers in Kubernetes, you just mention that these are the configurations I want for this mission, and it is up to Kubernetes how it manages it. It knows where to run the front end code, where to run the back end code, right, with what configurations and stuff like that. So basically, it's kind of a manager, right, captain for applications. Especially if you are running these containers in cloud. In cloud, we have a lot of other things, right? For example, we may want to have one mission in one region, right? Front end, maybe database in another region. When you bring a new database service, you have to go and then create in that region only, and you have to set up a lot of networking things. You have to take care of the computing, right? Dedicated computing, say, allocations. All these things Kubernetes can handle. So that's the reason we call it as what? Orchestration tool. So in sports world, we call it as captain, right, or coaching or coach. In application world, we call it as orchestration, right? That's a simple analogy for to make sure to make understand what exactly orchestration means. Okay, so as I mentioned, you see this in application world, some are web servers, authentication servers, search servers, payment gateway and stuff like that. Kubernetes comes along a bit like a coach in the football analogy or cricket. It organizes everything into a useful application and keeps things running smoothly. So basically, it knows, right, when a service goes down, how to bring a new container and with what parameters and stuff like that. So that's the meaning of orchestration, correct? Let me quickly explain the Kubernetes cluster, Kubernetes architecture at a very high level. then I will discuss few things. This is how Kubernetes architecture looks like. In Kubernetes, we have something called master server. This is master. And then here we have some worker nodes. Like in Jenkins, we have master slave concept, same thing here, right? You can have any number of worker nodes. All these worker nodes form a cluster basically. This is a cluster. That means these machines are attached to each other like this. When we create the containers don't run on a particular node, right? It runs on the cluster basically. Why this cluster is required? You see this, assume that this is your host machine, correct? Say we have hardware and then we have operating system. Then here we have say Docker installation and we run the container on top of this. This is Docker. What if this machine goes down? Assume that we have some 10 containers running on this host. If the host machine goes down, all containers also die. All containers will die, right? So how do you keep your containers running even though host go down? That's where we think about clustering concept. In clustering concept, what we do, say we have one mission right here. We create another mission. So this is one mission, right? This is another mission. And we attach these two missions. These two missions form a cluster. Cluster means a pool of missions basically, right? And you create the containers. So these containers are not particularly running on one host. It is running on the cluster. Cluster means like addition of multiple missions. Say for example, this mission may be having 8 GB. This has 8 GB again. So these containers use 16 GB. It's like you bring multiple missions and make it as a single compute unit, right? In this case, what happens? Even though one node goes down, you still have another node. So containers will not die. We can attach more and more, host missions, more and more nodes, and run our containers. For example, suddenly you want 1,000 containers, right? So what do we do when we need 1,000 containers? We need more compute power, right? More hardware. So you just go and then keep adding more and more host missions, more and more nodes. We call it a node basically. That's where Kubernetes helps us. So here we take multiple missions. We call this as worker node, worker node 1, worker node 2, worker node 3. 3 missions together forms a single computing unit. And then we attach these nodes, worker nodes, to the master, right? And when you create, when you need 100 containers, for example, your 100 containers run on this cluster, not on a particular node, right? All these nodes, 3 nodes become a single mission now. Think in that way. 3 node becomes a single computing unit, right? Single mission. So even one node goes down, we still have 2. In real time, like based on the requirement, we go and add multiple nodes. We call this as a Kubernetes cluster. I say in this cluster, I have one control plane, or you call it as master. I say in this Kubernetes cluster, I have one master and then 3 worker nodes. All these missions together, you call it as what? Kubernetes cluster. Okay. How it works? How you run your application? As I mentioned before, in Kubernetes, we write something called configuration file, right? YAML file. This is YAML, or extension can be YML. It can be anything. For example, deployment.YAML. You call this as manifest or declarative configuration file. Okay, so this is you, right? User. First, you develop the application. Okay, then you build the application. Once you build the application, then you create the image. Correct? Image. We have done that, right? So this is image basically. So you first develop the application, you clone the code, you build it, and then you create the image. with necessary dependencies, whatever you want, and then use this Kubernetes. One second. Just kidding. Sorry. So you develop the application, you build the application, then you create the image. Once the image is created, you upload it to Docker Hub, and then you give that image to your Kubernetes. So you take the image and 1, 2, 3. See, if the Kubernetes is not there, we have to take care of the application. We have to take care of environment creation. If Kubernetes is there, where Docker responsibility ends? Docker responsibility ends till image creation. That's all. Okay. And once the image is created, then we bring Kubernetes. So here you have to write this configuration file. For example, here I'll say I want to have 100 containers, and these 100 containers should be created from this image. What is that image? For example, in our case it is gamut cart hyphen image, and I want port number 8080 open in the particular container. So whatever you want, you write everything in your YAML file, and then you post this YAML file to master. That means we have to execute it. We call it the post basically here, or you think it as execute this particular YAML file, and we need 100 containers, right? This is the desired state. Kubernetes master will create 100 containers from this image, and you can set up the load balancer and everything, right? Basically, we say these containers are running in Kubernetes cluster, running under the supervision of Kubernetes. Okay, how that execution happens? In master, basically we have few services. The moment you write YAML file and then execute it in master, you know what master does? Master first reads your configurations. So master has something called API server here. Once it reads that, it goes and then stores that inside the database. Then there is somebody called scheduler here. Scheduler schedules container creation, and there is something called controller. Controller basically continuously checks whether actual state is matching desired state. So what is the service here? API server. This is kind of a front door for us. This is how we talk to Kubernetes. API server's responsibility is what? API server responsibility is to read your YAML file, and then YAML file has a desired state, right? It stores that desired state in this cluster store. What do you call this? Cluster store. This is basically HCD database. This is basically a database. So it acts as a database for Kubernetes. So basically whatever configurations you want, all your configurations are stored in the database. And that is called as cluster store. Cluster store is a service name, and this database is HCD database, right? For example, we have Oracle database, we have MongoDB, we have different databases, right? So Kubernetes uses HCD database to store the configurations. Once your configurations are read, stored in this cluster store, then comes this guy, scheduler. We actually call this as Kube API server, Kubernetes API server, Kube scheduler, Kube controller. So once this is the first step, this is the second step, then schedule comes here. It reads the database, it monitors the database for any new changes. The moment it detects some configurations here, what it will do? Scheduler goes to this particular cluster, and then it implements your configurations. So here everything is stored here. Scheduler takes the information, then what is it we want? 100, right? So it goes and then creates 100 containers on top of this particular cluster. So here you get 100 containers. If you had given, say for example, a load balancer setup, it will also set up the load balancer and then attach all these 100 containers to that. Okay, now using Kubernetes, you have created containers. Actually speaking, here we don't call these missions as containers. We call it something called pod, pod. For now, you think pod as a container. Okay, I'm not going to use that word for now. Let me use the word called containers only. Okay, once containers are created, then comes your controller. As I said before, Kubernetes don't just create the environment, it also continuously check the actual state. In case, right, the Kubernetes cluster is not at actual state, I mean not Kubernetes sorry, in case Kubernetes actual state is not matching the desired state, then controller informs scheduler again, and then it brings environment to that level. That means if 10 goes down, it is continuously monitoring, right? And it knows that there should be 100 because it treats the database, right? There should be 100 and then 10 went down, and then it will bring 10 automatically for us. Inside this controller, right? Inside the Kubernetes, we have the controller, right? This controller will actually create something called watch loops. What is that? Watch loop. It is like your cron tab. Okay, for every I mean periodically, for every 5 minutes or maybe 1 minute, it depends on like the software how they have configured, but it continuously monitors your thing by using something called watch loop. That's what they call. Think it as a cron tab basically, which will be running continuously. These are 4 main services we have in control plane or master. Okay, these containers are actually running on any one of these 3 worker nodes, correct? Okay, in worker node also we should have some services running. For example, in worker node we have something called, there is something called kubelet. Okay, kubelet. The moment scheduler checks some change here, the configuration change, it is scheduler which implements, right? So what scheduler does, scheduler connects to this particular kubelet. It will tell kubelet, hello kubelet, I need only 90 containers now. For example, you change the configuration from 100 to 90. It says, okay, I need 90. It is kubelet which will go on and say, for example, remove 10 containers. Assume that you said, I want 100 more containers, and then execute it. It is kubelet which will actually get your job done at the cluster level, right? At a worker node level. What kubelet does, we have image in where? Docker Hub, right? Docker Hub. We specified gamut cart image, so this is gamut cart -image. Okay. The moment now scheduler goes to kubelet will download that image from Docker Hub, and then it will call this guy Docker. Docker will create the container. So master is communicating to this worker nodes using what service? Kubelet, which is running in the cluster. For example, you take our Jenkins master slave concept. When master connects to the slave node first time, it will copy a jar file, right? Using jar file only, it will communicate. Using that code, it will communicate. That is this. You can call it as an agent software, master and then agent. In worker node, we also should have another service called kube proxy. What is that? Kube proxy. Kube proxy. KUBE proxy. Kube proxy is responsible for taking care of any network related configurations. You have 100 containers, right? You want 100 more containers. When you create 100 more containers, then you get 100 new IPs, and all those new IPs should be added to the load balancer, correct? Who will add, right, those new machines to the load balancer? It is kubeproxy. For example, you have 100, 10 containers go down, you bring 10 up, 10 new containers has new IPs. Who will take care of adding these 10 new IPs to the load balancer? It is kubeproxy. So basically, kubeproxy service takes care of all network related communicational tasks. So in worker node, we should have these 3 services. Clear with that? Kubelet, Docker, and then kubeproxy. Any questions so far? This is how Kubernetes works. Okay, this is Kubernetes architecture.
Naresh, one question here. If you can just go back to the slide. Yeah. So in case we have multiple kind of different this is a one of that image which will be but let's say we have container which required multiple application, like one is image, one for database interaction, database, one for some other application. So how like multiple applications will be we need to write the deploy ML file with multiple applications, or how it will be interacting with the control panel then, in case of multiple application need to be just bring in into the environment.
So we write all those things here in the YAML file only. So here I'm telling I want 100 containers from this image, right? We can also say this is one container. For example, this is for the Tomcat. If you want another container for the database, for example, we say again the container name should be this. Okay, for example, DB server, and this container should be created from say gamut DB image, for example, image, and then in this particular mission, I want say port number 8085 open. We give all the specification here basically, so we can do that. I want 10 containers from this image, 10 containers from this image, 5 from this image. We specify all those images and then container names in YAML file, and then you give it, and according to our configuration, it will create multiple containers here. Few maybe
So it will be
database, few maybe Tomcat.
So it will be keep monitoring all the containers one by one, and if there is any controller will keep monitoring, and in case any glitch into that, it will be just creating based on the container what is required specifically, right, for database, whether Tomcat or any other application, right?
Right, because it knows what user configuration should be, that it stores everything in the database, right? So controller takes that information and it will verify continuously. Yeah.
Okay, so the master. So the master, so the master database would have all the container information which are running for the different applications. Is that correct? If I'm not wrong.
Correct. You're right.
Okay. So that database also need to be configured for the master, or will it be kind of by default?
It's inbuilt. Sorry? We never work with it's inbuilt into the Kubernetes service. When we install Kubernetes, we get this. So we don't have to configure this specifically.
Okay. By default, it will be just reading from the container based on the multiple containers. It will be just adding that to the master database, and then controller will be keep running. If there is something glitch is there, it will be just going, and based on which container it is failing, it will be recreating that containers again based on how much. Okay. Thank you.
Okay. Can you clarify something other pods?
I'll take that. That's I think next topic. Let me finish few things, then I will come to that pods.
Okay, sir.
Okay. For now, just think, these are all the pods actually. When we say 100 containers, right, we create 100 pods. Inside 100 pods, we have a container. It's like, in Kubernetes, we cannot directly create the container. We have to first create the pod. Inside the pod, we have a container. So for now, think that these 100 are containers. Okay, I'll explain that. Before that, we have to be clear with few things, right? Let's continue. So here in worker node, we should have Docker, right? Because Docker is the one which Docker is a containerization software, right? It's not only Docker. You can have any other tools also which creates the container for us. For example, there is something called Rocket, RKT. It is also like Docker only. We can use Rocket. There is something called Container D. Container D. That's how we pronounce it. Container D. Container D, or it can be Docker, right? Docker. Container D is Docker only. So what Kubernetes people have done, they have taken the Docker and then separated the functionalities required for Kubernetes in order to create the containers. You can think Docker D as a stripped down version of Docker. It's kind of a trimmed down version of Docker. Container D is a smaller version of Docker, you can say, because they felt Docker tool is heavy here. That's the reason they have created this. So a lot of people started using the Container D also. Basically, what I mean to say here on our worker node, we should have one container runtime. We call it what? Container runtime, using which we can run the containers. Kubelet is kind of a agent software, and then kubeproxy takes care of network related things. That's what I have written here. Container D is a stripped down version of Docker. Okay, and we can now install. We can have any container runtime here. Okay, let's move on. This I have explained to you, right? How that the clustering software looks like. We have different clustering software. For example, we have something called Docker Swarm. We have not discussed that because we are learning Kubernetes, right? So Swarm is kind of nobody's using it. Maybe like old projects may be using. Swarm is like Kubernetes only, but it's not. It doesn't have all these features like automatic rollback, rolling updates, self-healing. It doesn't have, but it acts as a cluster software. That means if there is no Kubernetes, what you do? You have to take 2 or 3 machines using Swarm commands. You have to attach these 3 machines together to make a single computing unit, and then you have to run our containers on that cluster. So if one goes down, you have other 2. So using Swarm also, you can join multiple machines to form one basically, right? That's a default feature comes in Docker. Docker has Swarm by default. There is another clustering software which will help us to connect multiple machines to form one compute unit. That is DCOS from the Mesospheres company. That's a company name. Then we have Kubernetes. So in 2016-17, there were a lot of discussions, right, about which clustering software is good and things like that. And obviously, Kubernetes won the game because it has the experience of running millions of containers. It has the Google's experience of running large scale applications. So Kubernetes is not just clustering software. It has a lot of extra orchestration capabilities, right? Just to give the name, just to tell what is that clustering software. Okay, it can be Swarm, it can be DCOS, or it can be Kubernetes. If you know Kubernetes, then Swarm is not required for us. Okay, Kubernetes is also called as a data center operating system, right? Why we call Kubernetes as data center operating system? You see this? When we write the application, for example, this is your calculator application. Once we develop the calculator application, they assume that it's a code, right? What do? We run this particular calculator code on some operating system, right? This is OS. This is called as system software. This is called as application software. So we run application software on system software. When we write the code for calculator, do we write the code to manage the compute? Like, to run this particular code, I need 2 GB RAM, right? I need this much of hard disk space. I need this much, the passing power. Do we write that in code? No, right? Like in C, if you remember, at least if you can, remember something about your college, say, things. In C, what we do, we have to allocate memory. We have say flexibility of allocating the memory. In older low-level languages, we had to define the memory also. For example, when I say a is equal to 10, we have to say, okay, to store this particular number, allocate this many MBs, for example, 2 MB, 3 MB. We used to do that. But these days in modern, high-level programming languages, we just worry about what? Our application functionalities, not allocating, the computing quotas, correct? And who takes care of all these things? It is this operating system. Operating system know how much RAM, CPU, hard disk has to be allocated to this particular calculator application. So this is the operating system job. We call Kubernetes as data center operating system. Means what? Assume that this is your data center, right? This is where you have your Kubernetes, right, which acts as kind of a OS. And this is your application basically. Assume that you have different services, front end, the back end, your messaging system, card service, database, and things like that. All things together becomes application, correct? So basically, you have to also take care of running these services, different services in different regions. You may be having, different regions in your cloud. This is your cloud data center, correct? Maybe the say Mumbai zone, maybe North Carolina, and then there are different things basically, correct? Different regions. So you may want to run service 1 in one region, service 2 here, 3 here, 4 here, and then things like that. And when you have multiple services, it becomes very difficult for you to go and then decide, what configuration is sorry, what configuration is required, for the mission which is running this particular service. What configuration is required, right? And what should be those firewall rules? How should how you restrict the communication between these two? You may not want these two services running, these two services talking each other, right? And then compute and a lot of things basically here. So since here Kubernetes manages all these things, for us, we call this as what? Data center OS. These days we try to see the complete data center as a single compute unit, right? So who is actually hiding all this memory allocation headaches for us? It is the operating system. Here, who is hiding, who is simplifying allocation of all this, say, resources and then regions and stuff like that in cloud? Kubernetes. So you call Kubernetes as a data center operating system. It says you just tell me what you want, right? At a very high level, you write everything in the YAML file, give it to Kubernetes. Kubernetes can manage all your services in the data center. So you call it as data center operating system. Just a theory for you. Okay, for orchestration, I gave you one analogy, right? In sports, it's a manager who manages, who gives the plan basically. In application world, it is Kubernetes, right? It knows everything, right? Where to run what. A simple analogy for you here. You see this, you take to understand this data center OS effectively, you can take this courier thing, right? So what do we do? This is you, right? When you want to post something to some destination, what do? We just put a label on that, right? Okay, address, and then give it to the courier guy. Do we manage, do we worry how this label is shipped to the destination, to the plane, to a ship, or all the logistics part? We don't worry, right? Who is taking care of all that logistic part? It's that courier company. So this guy is actually managing everything here, right? Like this guy here, it is Kubernetes which manages a lot of stuff for us, right? So where to run what service and things like that. So you just tell at a very high level what you want, right? Okay, this is what I want. Just give a label, that's all. Hand it over to Kubernetes guy. What you want, you write everything in the YAML file, hand it over to Kubernetes. Kubernetes can take care of the things for us. Kubernetes is called as data center operating system. Okay, this is the conclusion. Okay, the theory part. Read this. You develop your application with Docker and then use Kubernetes to run it or orchestrate it. Correct? That means using Docker, you just create the image, that's all, and then hand it over to Kubernetes. We use Kubernetes to deploy that particular image in test, production, or any other environments. You can get any number of environments in your Kubernetes cluster. It's not just the product, and all your environments are here. So this is, for example, flipkart.com. You can get another set of containers here. You can call it as flipkart-sit.com and things like that. So you create the image and then you bring Kubernetes to manage your test or say a production environments. It can be anything, right? Okay. Kubernetes and Docker both are called as what? Complementary technologies. Means what? See, both like complement each other. Docker says, okay, yes, I'm good. I'm the one who is creating the container, but without you, I'm not very effective. Correct? Kubernetes says, okay, I don't, do your job, right? I just manage the things, but it is you, the workhorse, like who actually done the things. If you can have both, then you can really run your application with all those orchestration capabilities. Okay, that's the conclusion here. And Kubernetes is called as data center operating system. Okay, any questions so far? Whatever architectural diagram I drawn, I have kept all those things here. Okay, you can go through this. API server, scheduler, controller. This is the database, and in the worker node side, we should have what? Remember this kubelet, container runtime. It can be Docker or it can be containerd or anything. And this is network proxy, or you call it as kube proxy. It can be anything. I just explained what API server does, what scheduler does, and then what this kubelet does here in these slides, which I have already explained. So I'm not going to walk you through the slides. One note here, okay, these worker nodes should be either VM or say physical machine or bare metal. So basically what I mean to say, there should be one operating system here, a complete copy of the operating system. Why? Because these containers are created on these worker nodes, right? On these nodes only. So you should have a full-blown copy of the operating system there. Your worker nodes cannot be containers. Why? If it's a container, what happens? You cannot create containers on top of another container, right? To create the container, you need to have the host machine, right? That means operating system. So these missions, worker nodes, should be either VM or cloud or bare metal servers. I mean, VMs are physical machines. That means the cloud instance, like EC2 instance or whatever. Okay, this is it. Okay, say for example, master makes scheduling decisions on the whole, monitors the cluster, implements the changes, responds to the events using all these services, right? So it is actually the scheduler which will schedule it, controller which will monitor, it is scheduler which will implement it, right? And say for example, in this cluster, I mean worker node, if one worker node goes down, then master knows that yes, it has to shift all the containers which are running on that particular worker node on top of other worker nodes. So basically master takes care of all these things. So it has API server. For example, API server, see this. Think of API server.
In a case, if one this one node is got down, so how all the detail will get again? Suppose this one node, partner node, third node, it's got down and crashed. Okay, all the data got lost, whatever there in the that nodes. worker nodes, 3. So how the master node will get?
No, if for example your application is running some, if your application is generating some data, and say you have the data here, application generated data. If that container gets crashed, nobody can recover the data. So what Kubernetes does, Kubernetes will just bring the replacement for that from the given image. So whatever you have in the image, that comes here, right? But if there is any data, for example, we know the volume concept, correct? We can create a volume, right, somewhere here in our cluster, and then we can attach that volume to this particular, say, container. So container is writing that information in this particular, right, volume, and then that is synced here. Even if this container goes down, your data you have here in your host. We can do that basically.
Okay. And that master is keeping the metadata about this work node, or what exactly? That DB you are talking about.
This contains your information, like our configuration, basically, whatever we need.
And he's not keeping all the data about the worker nodes detail about the metadata.
Yeah, it keeps the data about our cluster also. It keeps that data also.
Okay, then scheduler, what is doing exactly? The master node will give the assign the task to the each worker node, or what?
It is scheduler which is connecting to some worker node, right? And then calling this kubelet. Kubelet will pull the image. It will pass it to the Docker. Docker will create the container.
Then master node assigning that particular task to the each worker node using the scheduler.
Yeah, correct. Yes. If you talk about the master functionality, all 4 functionalities, that's what master handles. Yeah, master will tell Kubernetes, scheduler will go and get the thing done.
But I cannot direct connect to the work node. Am I correct? Or I will directly connect to the work node, because if I will connect to master, again master going to connect to work node. That is again what no communication is taking long time. Suppose I requested something to build. Okay, I'm going to master. Again, my master is going to talk to worker node.
So that's what, right? In master,
go to worker node, I cannot connect to direct to worker node.
We can connect to the worker node directly. I mean, we can do the SSH things like that, but we don't directly, run some tasks here. We have to give everything to the master. So we talk to the master only. For example, like you take, say, Jenkins master slave concept. You want to run the builds. Where do we put all the configurations? In the master only, right? We cannot go to each and every slave node and then do the build, right? In that case, then we have to manage a lot of things. It's a maintenance headache, right? So it's a kind of a single point of contact. You just go and tell what you want here. This guy will get it done for you instead of we going to each and every worker node and then
what I believe here, if I'll go to the master will give the metadata to me, and that metadata I will connect to the particular work node. Like that will happen, or
no.
Nothing
So
like that.
we have this data, correct?
Okay.
You give the data to the master. Master will give you, the containers accordingly.
Okay.
When it's a metadata, right? For example, like how many clusters, how many nodes are present in this cluster? Which node is, for example, already overloaded? For example, 100 containers, right? Yeah. So here, like you have 50, and then it's a 50 containers are running, for example. And so this is running, say, 100 containers, for example. 100 containers are on this worker node. You ask 100 more. So what it has to do basically, it should not again go and create containers on top of this, using this worker node's hardware, right? What it has to do, it has to go and find out which worker node has a less load. So it will go and do it. By default here, it balances the load basically. You have the round robin algorithm here. So when it has to, when it creates the containers, it knows the state of the worker node, and it must be keeping all those nodes information in the database, like you call it as metadata.
Okay.
Sir, what happens if some worker node goes down? Like if there's 3 worker nodes here, if something goes down, then what happens actually?
If one worker node go down, then containers won't die basically, because we still have 2 worker nodes. It is just that these containers will be shifted to other 2 worker nodes, and we should have maybe some alert mechanism. We should know that okay, worker node went down, so we have to go and then attach one more worker node.
And in cloud environment, and that is the work of the ECS, right? In something like Amazon.
Yeah, in cloud environment, if we have say if we are using Kubernetes cluster, Kubernetes service, for example, in AWS we have K8s, right? AWS Amazon Kubernetes service. If it is a cloud, we don't need to worry about this. If we are using their service, if one node goes down, right, it brings other node. Basically, cloud says you don't worry about how many worker nodes I have. You tell me what you want, and then it just runs it. So in cloud, we don't need to worry about how many worker nodes we have, how many went down, and all the stuff. They manage the complete Kubernetes installation, Kubernetes cluster, and we take that as a service.
Okay, again, if the master node goes down, then what will happen?
Then that's all. If master itself goes down, then we cannot track anything here. Application, if the containers are running, or containers are running, but we cannot communicate and we cannot say roll out any changes to this. So that's the reason usually we create the master in some cloud. So cloud always gives that guarantee, right? So 99.99% uptime. So we prefer to
actually, I thought
create this. We prefer to create this master on the cloud. We can also attach one more master if you want. High availability. If one master goes down, right, other master takes that complete activity. We can have 2 masters in one Kubernetes cluster as well.
Okay. Oh, so is it like that, or some of the worker node will become a master in that case? Will it not happen?
That is not there. We have to have one master and then switch to it. That auto switch, when we implement this high availability, then that happens.
Okay, then the backup of everything it has to be there, updated with the other one too.
Yes, correct. Whatever data you have here, so we need to keep syncing this data from here to here.
Okay.
Or if you want to prefer, this say worker node. If you want to make this worker node as a master, you can do it, but it cannot take that at a software level or the tool level. You cannot say this went down and then you take charge. So no, at the tool side that is not it. We have to actually, it's like you are taking a mission and then doing something, making it as a master.
Okay. Thank you, sir.
Yeah, no problem.
One question here, as you said, based on high availability, we can just attach one more master control plane. It will be, master would have some application running on right, the state of that next, since you are telling it will be syncing, right?
We don't run applications
the state
on
will not be
master. We don't run applications on master. We run applications
not
on
application, but the master would have their own application which manage that database and those things, right? So the state would might change since we are running some like a worker node and a cluster which we are running, right? So something which might be updating this data, but the synchronization to the second master is not. It's still syncing between it get crashed, right? So how it will be like synchronized between those two, how it will be switching back to, because still it's writing some data to the master, right?
Correct. So that sync happens always. So when we have 2 masters, for example, master 1, master 2, right? And this master 2 and master 1 all are, both are always connected. If some information comes here, right, that information will be synced here. So it's a very quick. That's a software excellence basically, right? So
Okay.
using which we can manage these 2 masters. This is not a manual activity. So there are some commands basically to attach, one master with other master, and then the sync happens automatically, right, by that Kubernetes say code or functionalities. We really don't worry about that, but there may be, I don't know, 0.01% the data loss maybe might happen. I don't know, because see, even though it is syncing, it may be taking at least some like 1 millisecond, for example. What if in that millisecond, this goes down, it is getting some data from here, and then it goes down basically. So this is not captured here, not synced, right? So
Right.
there can be something, some kind of a glitch, right? Something maybe that happens basically, but I never heard about that.
Okay.
I think it's good to master.
Okay. So one more question here is based on the worker node. Let's say if we have defined 3 set of worker nodes right now. One get down. If anybody would like to add it, do they need to means configure into the scheduler or somewhere, or how they will be adding?
We have a way to add a worker node to the master. Like when we create the master, we get a command basically. We get basically some key. We need that key. Using that key, we can add this. There is a command to add that. For example, you can say kubadm add this mission to this missions. We give that IP address. There's a command for that basically.
So means it will be a quick just addition to the. Okay.
Yeah. For example, we give something like this, kubadm join. Right. We run this command inside the worker node. So kubadm join. This is the master, and then we have that key token here. You give the token, and then that mission will be attached to the master. Just it takes a few seconds. That's all.
Okay. Yeah, got it. Thanks.
Anyway, we'll be doing that later. I mean, we'll be attaching worker nodes to the master for sure.